In this video, we're talking about how to use the quadratic formula to find the roots of a quadratic equation. And in this particular problem, the quadratic equation we've been given is 3x squared minus 2x plus 5 equals 0. Now, when you first look at this equation, you should think about factoring it because it's a trinomial, a polynomial with 3 terms on the left-hand side of the equal sign here. So we might be able to factor it. But if we try to factor it, what we realize is that the factors of 3 here in front are 3 and 1. The factors of 5 are 5 and 1, and the only way we could combine these to get to 2 is if we did 3x and x here, and we did minus 5 and plus 1. That would give us negative 2x in the middle. If we FOILed this out, you can see we'd get 3x squared when we multiply 3x by x. 3x times 1 would give us plus 3x. Negative 5 times x would give us negative 5x, and then we'd have negative 5 times 1 is a negative 5. When we combine like terms, we'd get 3x squared. 3x minus 5x is a negative 2x. And then a negative 5. So you can see it's the same as our original equation, except that in the original equation we have a positive 5, and here we have a negative 5, and so it's not the same thing. So this factoring here is incorrect. We can't actually factor it that way, which means that we can't factor this to find the roots. And in that case, one way that we can find the roots is by using the quadratic formula. And if you remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And these a, b, and c values come from the standard form of a quadratic equation, where a, b, and c are the coefficients in front of x squared, x, and just our whole number here, respectively. So we have to take these values of a, b, and c and plug them into this formula to find the roots of this equation, since we can't find the roots by factoring. So we need to identify our values for a, b, and c. Well, a comes from the coefficient in front of the x squared term. So in our case, we can see that a is equal to 3. So we'll say a equals 3. B comes from the coefficient in front of x. And in our case, that's negative 2. We have to remember to include the negative sign there. That's really important. So b in our case is going to be equal to negative 2. And then c is the whole number. And for us, that's 5. So we're going to say c is equal to 5. Now with these values in hand, what we want to do is plug them into our quadratic formula here. We'll go ahead and say x is equal to, because this is going to be the root or the solution to the quadratic equation, so the solution is going to be equal to negative b or the opposite of b. So we're going to say negative, and then b is negative 2, so negative 2 plus or minus the square root of b squared. Well, b is negative 2, so we'll get negative 2 squared minus 4 times a, which is 3, times c, which is 5. That's going to be under our square root sign. And then this is all divided by 2 times a, and a is 3, so 2 times 3 in our case. So when we simplify, we're going to get x is equal to negative 2. These two cancel to become a positive, and we get positive 2, plus or minus the square root of negative 2 squared, which is going to be a positive 4. 4 times 3 is 12. 12 times 5 is 60, so we're going to get minus 60, all divided by 2 times 3, which is going to be 6. We still need to simplify what's underneath the square root sign, so we'll get 2 plus or minus the square root of negative 56, all divided by 6. Now at this point, whenever you end up with a negative underneath your square root sign, what you want to do is factor out this negative 1 and make this a positive 56 times a negative 1, and we'll break those apart into separate square roots. So this is going to become x is equal to 2 plus or minus the square root of 56 times the square root of negative 1, all divided by 6. Now we can take the square root of negative 1 separately as an imaginary number and deal with this positive value here. Remember that the square root of 56 is the same thing as the square root of 8 times the square root of 7, because 8 times 7 is 56. We know that 8 is 4 times 2, so we can say that the square root of 8 is the same as the square root of 4 times the square root of 2. Now we can take the square root of 2. We know that the square root of 2 is 4, so we're going to get x is equal to 2 plus or minus 2. That takes care of the square root of 4. Then we have the square root of 2 times the square root of 7, or just the square root of 14. And we know, because we factor that into two prime numbers, 7 and 2, that we can't simplify the square root of 14 any further. And then we have times the square root of negative 1, all divided by 6. From here, we can divide through every term by 2, and we're going to get x is equal to 2 divided by 2 is 1, plus or minus 2 divided by 2 is 1, so that 1 disappears, and we just get square root of 4 times the square root of negative 1, all divided by 6 divided by 2, which we know is 3. Now remember that when we're dealing with the square root of -1, we call that the imaginary number I, so we can replace this square root of -1 with I, and we get x is equal to 1 plus or minus the square root of 14 times I, all divided by 3. And now we've simplified as much as possible, so these represent the two solutions to the quadratic equation we were given. If we want to write them separately, we can say that we have the two solutions, x is equal to 1 plus root 14 times I, all divided by 3, and 1 minus root 14 times I, all divided by 3. So you can write them separately this way, one with the plus sign, one with the minus sign, or you can combine them into one fraction like this and just say 1 plus or minus the square root of 14I over 3. Either way, these represent the two solutions to the quadratic equation, which we found using the quadratic formula.